Welcome to this Vedesta service information film. Today's topic is Spirit equipped with SeedEye if customers report seed counting alarms 1050. Always remember safety first. Before starting any work on the machine, make sure to take necessary safety precautions. Always follow the safety instructions found in the user manual of the machine you're going to work on. Alarm 1050. If we look this up in the eControl user manual, we will find the description imbalance seed boxes. One or more seed meters are delivering a greater amount of seed. Since we're running seed counting, this is the quantity of seed. The difference to trigger this alarm is bigger than 10%, and this is a non-adjustable alarm value. If we continue looking in the alarm list, we will find a recommended action. And the recommended action is to perform a normal pulses per kilo calibration. In this way, we can ensure there are no mechanical issues relating to the feed housing. The secondary check, and the main topic of today's film, is to verify the function of the motor encoder, the rev counter of the electric motor found in the Phoenix 2. In the next chapter, we will look at the function of the sensors that are included in the Phoenix 2 housing. These sensors are some of the most important sensors included in the machine. They are used for two purposes. One sensor has the main function to control the speed of the Phoenix 2 electric motor, and the other sensor is used to monitor the movement of the feed roller. We normally call this the rotation guard sensor. Since there are two sensors that are powered by the same electric motor, we can use one sensor to verify the function of the other sensor. They are connected to the same shaft. The only tool you need is the service menu in the eControl app in your iPad. The Phoenix 2 has the two sensors. The motor encoder gives us 12 pulses per revolution, and the rotation guard sensor gives us 8 pulses per revolution. Let's look at what this looks like in real life. At the back of the electric motor, inside the housing, we have the motor encoder with 12 pulses per revolution. On the other side of the housing, we have the inductive sensor. This is the rotation guard, and the rotation guard reads the metal ring that is fitted to the feed roller. So we can see we have here 8 metal lugs that will give us 8 pulses per revolution. To make things a little more complex, we also have the two stages in the gearbox. We have two speeds. We have the high speed and the low speed. But if we look at the system, we can clearly see that the metal ring is mechanically connected to the encoder at the back of the electric motor. These two have a fixed ratio to one another. So let's have a look at gearboxes. We have the external gear, high or low gear. In high gear, the speed from the motor is increased. So one revolution of the electric motor gives us 1.7 rotations of the feed roller. And in low gear, we have a reduction. Also, before we reach the external gear, we have the motor planetary gear, which has a reduction of 36 revolutions of the motor to 1 rotation of the output shaft of the motor. If we do the maths and we calculate the gearing from sensor to sensor, we can see that in high gear we have a ratio of 31 to 1. This means 31 motor pulses equals 1 rotation guard pulse. And in low gear, we have 94 motor speed pulses for 1 rotation guard pulse. These are fixed ratios, and this is what you expect to see when you run the machine. You expect to have 31 pulses from one sensor for every single pulse from the other sensor. If you do not have that value, you are either in low gear, and then you expect to see 94 pulses from the motor for 1 pulse from the feed roller. If you don't have a relationship of 31:1 or 94:1, there are some problems in the system. Now we know the function of the Phoenix 2 sensors. Let's look at what this looks like in the service menu of eControl. So we're looking at a Spirit 6-meter machine. We go to the information page and we go to VS9 inputs. What we want to look for here is the motor speed counters, as you can see on top of the picture. Motor speed for the left seat housing, the rotation guard for the left seat housing, and the same for the right. As you can see, these are counters. That means they accumulate the value. Every time you restart the gateway, these values go back to 0. What we're going to do now is go back to the front page, and we will run pre-fill, manual fill. This will run the motors, make them spin. We see that we are running right now a fairly low rate at 12 kilometers per hour. We will continue to do this for a while to gather pulses. Right now, the motor speed is controlled by the motor encoder, and the rotation is monitored by the rotation guard sensor. I think that's enough. We'll go back to the information menu, and we find the motor pulses. We can see that the left housing, the motor, has counted 18,078 pulses, and the rotation guard 192. So let's calculate if we have the right values. Now we have completed the test, we have some data. Let's calculate the numbers. Remember that if we are in high gear, the motor speed pulses divided by the rotation guard pulses should give us a result very close to 31. If we're in low gear, the motor speed pulses divided by the rotation guard pulses should give us a result of 94. We have in our case 18,078 pulses. We divide that by the rotation guard pulses, which is 192, and that gives us a result of 94.1. This is very close to 94, so we can conclude that the motor speed sensor, which is responsible for controlling the speed of the motor, is working correctly for the left motor. If we look at the right motor, 17,833 pulses divided by 190 gives us a result of 93.86, which is also very close to 94. So we can conclude that the test we just did show that both the left and the right Phoenix 2 seed motor sensors, the speed sensors, the encoders, are working correctly. The key numbers to remember is 31 and 94, and the only tool you need is the service menu in the eControl app. And that concludes this service information for Spirit with SeedEye relating to seed counting and alarm 1050.